Good morning, Devoxx. Welcome to my serverless deep dive. So my plans for this morning are to give you a glimpse into the future of the cloud. And I think serverless will play a big role in that in the next years to come. So before we all dive into that, just do a quick introduction. My name is Bert Ertman. I'm a fellow at Luminis in the Netherlands. We're based in the Netherlands, but we also have offices in the UK and the US. What we do is consultancy services, projects for our customers, and we also do product development and a lot of open source involvement. I've been fortunate enough to have been around Java for the last 20 plus years. I ran into it when it was about 1 or 2 weeks old while I was doing my internship. And I actually never left doing Java for my entire career. And besides working with Java, I also like to speak at conferences, perform trainings, etc. So much about me. Let's talk about serverless. And I'd like to start off this talk by giving you a picture of what the evolution of compute looks like from my point of view. So it was not that long ago, if you look at the left-hand side of this picture, when we were actually running our software on physical hardware. Right? If you think about it, maybe 15 years ago, it was like pretty common to run software directly on hardware, right? And this hardware was either under your desk or it was down with a lot of other hardware boxes somewhere in the cellar. Now, beyond physical stuff, we've been virtualizing stuff, which basically meant we bought bigger boxes and then we ran like a guest, and then a whole slew of guest operating systems on top of it, right? So we started virtualizing our servers by running more servers on one physical box. And then at some point in time, let's say maybe 8 years ago or I think maybe 8 years ago, we moved this virtualization stuff from our own data center to somebody else's data center, which we now call the cloud, right? So this is not where the story stops, right? So for the last 2 or 3 years, people have been very busy with containers. Think Docker and others, right? So who here has experience with Docker? All right, that's like half of you. Okay, good. So some of you think that containers are actually our, well, most pure form of virtualization these days, right? Or most cheap or most lightweight form of virtualization these days. But as I will try to point out in the remainder of this talk, is that we now have a new highlight in terms of both virtualization, also in terms of compute, where we talk about serverless or actually running functions as a virtualization or abstraction mechanism. So first question to ask when somebody starts talking about new technology is why on earth do we actually need it, right? Or what problems is it trying to solve that we have now, right? And this question isn't asked enough these days. I mean, we're really eager into using new technology whenever it sees the light of day, but we should actually always question why first. So the why for serverless is basically twofold. So far, as I was showing you on the evolution of compute cycle, we have been virtualizing servers, right? And we care for servers. Actually, we care so much for servers that we actually give them names, right? And we take care of them, right? And we give them lots of attention. And we are really upset when the server goes belly up. So in a way, it's just like with pets, right? So we care for servers as we care for pets. And what we actually are most interested in is not the server so much, but we are actually interested in the output, basically in what I like to call the compute, right? Or the produce of the server, if you compare that to cattle, for example. So with cattle, we are no longer interested in the individual animal, but we are interested in what the animal is actually producing, being it meat or milk or whatever, right? And so if one or more animals are underperforming, you just switch them out, you replace them, right, with another animal. And the same thing should be said of servers. So we are no longer interested in individual servers, but we are interested in their produce, and their produce happens to be compute power. So as we're interested in compute power, right, we should no longer care about servers, hence the name serverless. So that's the first thing. The second thing is that if you think about the original promise of the cloud, right, it was that we were about to pay only for the stuff that we are actually using. Right? Pay as you go. That's what the first acronym means, pay-go, right? Pay as you go. But then, in reality, if you look back over the past 5 to 8 years, we have been paying for everything in the cloud, which is the second acronym. I made it up myself, which means pay as you go and also as you don't go. right? So, okay, not very strong acronym, but anyway, I think you get it, right? So we pay for everything in the cloud these days, right? So therefore, virtualizing in the cloud is not cheaper per se, right? So we pay for everything. And going back to that original promise, we only want to pay for stuff that we are actually using, right? And that also fits really well with the time that we live in. I mean, in this day and age, we probably like to pay for stuff that we use, but we don't necessarily have to own it, right? We don't have to own everything. We just want to make use of it. So the same thing goes for the cloud, right? If you consider the cloud somebody else's data center, which produces compute, then we are interested in using that compute power every now and then. But if we don't use that compute power, then we don't want to pay for it, right? So for those two things, that's where serverless was invented for. So I think the whole hype around serverless started off around 3 years ago when Werner Vogels, the CTO of Amazon, came up with this quote at a reInvent conference. I think it was back in 2014 or something. And he said, well, no server is easier to manage than no server, right? And he's absolutely right about that. And this is where the whole serverless thing actually took off. So let's think about the name for a few seconds. So the name is actually kind of weird, right? Serverless. So apparently there are no servers involved. Well, spoiler alert, this is not true, right? There are still servers involved with serverless, but you don't see them, right? It talks about the programming model. So from a developer standpoint, as developers, we're interested in compute, but we're not interested in managing servers. So in the programming model for serverless implementations, you will not see anything that resembles a server. Right, so that's what the name actually is about. The funny thing is, though, that the name mostly describes something which it is not, right? Just like with NoSQL, for example, right? So we have a bunch of databases, right? The only thing they have in common is that they don't have SQL as a query language, so let's call it NoSQL. Well, same thing with serverless. You will see many implementations, and the only thing that they have in common is that there are no servers or virtual machines or whatever visible in the programming model. Now, serverless is known by a bunch of names. So some people call it functions as a service. Actually, there's a difference between serverless and functions as a service. I'll talk about that later on in the presentation. But some people think that serverless is about functions as a service, right? And functions are first-class citizens in serverless implementations, and we'll talk about that a lot. Or if you want to be boardroom compliant, right, you got to have your Gartner speak. So in terms of Gartner, it's called function PaaS, right? So functions on a platform as a service. And then there's people that say, well, serverless and functions, let's call it backend as a service, right? All right, so this is actually a bit of a funny name, right? So imagine tonight, I mean, when we're done doing this talk and all the other talk today, you're sitting in the bar of your hotel, maybe, and then you talk to your coworker. You say, well, that's what interesting stuff, right? Backend as a service. And then there's some other people sitting next to you. They have no clue about IT, but they hear you talking about this thing, backend as a service. And, you know, what must they think, right? Yeah. I know there's a code of conduct here, so I try to be compliant. All right. So with every piece of technology or framework or semantics or paradigm that's introduced these days, if you want to be taken seriously, then you got to have a manifesto, right? So does the serverless movement. They have their own manifesto. So I'll walk you through it. So first and foremost, serverless is about functions, right? So it's functions are your unit of deployment and your unit of scaling. So when we start developing software, and I'll do many demos later on, we have to think in terms of functions, right? So we are no longer thinking in terms of applications, but we're thinking smaller functions. I hear some of you think microservices maybe. Well, let's save that for later. Functions for now, right? So functions is what we develop. Functions are what we deploy, right? And functions is also your unit of scaling, which means that all requests to your function are being scaled on a per function basis. And this is nice because now you get a single-threaded programming model. Like I mentioned before, from a developer's point of view, we have no clue about underlying machines, virtual machines or containers, right? So you just don't see them. You only see functions and APIs, and that's about it, right? You have no clue if there's a big processor underneath or small one, whether it has a lot of memory, whether it has a very tiny amount of memory. That's all up to your provider, all up to your cloud provider to supply you with just enough processing power, just enough memory, depending on the use of your function. We'll talk about that later too. Functions are inherently stateless, at least for now, right? Which means that if you gotta have storage somewhere, right, then it must be some form of a database or an intermediate cache or whatever, right? So it's up to your function, if you want to remember something after the function is done, to write it out in a database somewhere, right? So permanent storage is still available, but then you could think of a database, especially in the cloud, as a serverless thing too, right? So there's someone providing you with a database management system, whether it's SQL or NoSQL, that doesn't really matter, right? You have no clue whether there's servers running underneath there too, right? So you have no clue whether it's 5 servers or 10 or whether it's just one really big one, right? You just use the database service, right? So you should think of those kind of services as serverless too. Serverless scales per request, right, which results from the first bullet actually, right? So functions are your unit of scaling. So the cool thing about this is that you can never under or over provision, right? And this is a big problem in terms of getting stuff off the ground, right? So imagine you're a web shop, right? And well, Christmas is coming, so you got to prepare for a huge peak load, hopefully, right? So traditionally in the cloud, this is a problem because this means that you have to have multiple instances ready for your application so that in order when it gets busy, right, you can scale out. Now the thing with cloud nowadays is that if you have a bunch of CPUs either idle or on hot standby or whatever, you pay for them, whether you're actually using them or not. The cool thing about functions is that you don't pay for it. So as long as nobody is there calling your function, you don't pay anything, right? So the code is just laying around doing nothing, you don't pay anything. As soon as people start hitting your functionality, right, that's when you start paying. So if there's like a single user, you pay a tiny amount of money. If there's like 1 million users at the same time, the scaling issue is up to your cloud provider. So your cloud provider has to come up with lots of compute capacity in order to run all those requests simultaneously. And then you start paying more money, but you only pay for what you actually use. So in terms of running a web shop where you have to deal with all of this over and under capacity, or when you run a startup and you only have a small amount of money, you need to get in business first before you can scale out and scale up, right? This is really interesting model because you don't pay for stuff that you don't use, right? And the fact that you don't have to think about over or under capacity, that is actually really interesting because it makes your life simpler as a developer. So I already mentioned this, right? So we never pay for stuff that is idle, whether they're cold servers or hot standby, or whether they're containers waiting to be fired up, right? If you don't use stuff in a serverless world, you don't pay for it. Then another interesting benefit from this function model is that we have implicit fault tolerance because we scale per function. So if somebody triggers your function and it starts to run and somehow it fails, right, then the only thing that fails is actually that particular instance. So all of your other users, right, they have their own instance of that function. So they are not, well, they're not affected, so to say, right? So you're implicitly fault tolerant because your functions can run on any piece of hardware that your cloud provider supplies, right? So if the underlying machine actually goes down or has problems, then it's up to the cloud provider to move your functions to somewhere else in the cloud, right, where it can run, right? So it's their problem. It's basically the man behind the curtain which is taking care of all of this for you. Then it's bring your own code, and this means, well, depending on your cloud provider, this means pick a language that you like, write a function implementation, then deploy it at your cloud provider, define a trigger, and this is how we will run your function. Now, the languages which are supported, of course, vary per cloud provider. We'll talk a little bit about that later when we talk about the different implementations which are out there. But basically, you just craft a piece of code into a function, which means it has input, it has output. You zip it up and you upload it into the cloud. That's basically what you do. And then finally, in a serverless world, you are entitled to metrics and logging as a universal right, for whatever that means, right? So basically what that means is that all of the cloud providers which offer you a serverless implementation, they also offer you some form of centralized logging, which means that you can either use a logging framework or you can just write a standard out, and then the cloud provider will collect your logs and will make them available to you from a centralized place. And the same thing for metrics, right? So the cloud provider should enable metrics for all of your functions, so you can see that when they were triggered, for how long they run, how many times they actually ran, whether they failed or whether they were successful, etc., etc. I will show all of this to you later on. All right, so summarizing this, right? From a developer's perspective, there's no servers to administer, right? So there's no infrastructure visible in the programming model except for explicit services that we use, say a message queue or a database, right? But we have no clue about servers, so we don't have to scale them, right? So we get automatic scaling, we get automatic failover. And the other benefit is that we only pay for the code that is actually being run, right? So if we create something beautiful, we zip it up, we upload it into the cloud, and nobody ever triggers it, we are never going to pay a cent for having that code available, right? But then if we have lots of users, right, then we will start paying, but only for the stuff that we are actually using. So we are not paying for overcapacity. When your servers are idle for 90% of the time, right, we don't pay for that. So in other words, we are no longer caring about applications, and therefore we are no longer caring for application servers, right? And also in terms of containers, containers are also not visible in the serverless programming model, which means that if you've invested big time into Docker, but you like this serverless paradigm, right, you can forget all about Docker, right? So sad for little Will over there, but I mean, unfortunately, containers, application servers, in a serverless world, they have no meaning to developers anymore. And then the marketing slide, right? You'll get short turnaround, because you just write a piece of code, you upload it into the cloud, you define your trigger, and it's there, right? So it's really easy because it's on a smaller scale. It is really easy to build something and have it ready. If it works, it will automatically scale, which is cool for startups, right? And then I mentioned this a couple times, it's pay-as-you-go only. All right, well, this is like the general introduction. So far, it sounds just like benefits, right? But we should be aware that we've only seen the hammer, right? So we've seen a hammer now, it's called serverless, and now we should be careful that not everything is a nail, right? So we should figure out how this model actually works and where it doesn't fit. So let's take a second look. So functions, right? We have a clue what functions are, right? So it's a piece of logic, you give it some input, it will have some output. Hopefully it's reproducible, right? What we need for this is that we need some sort of a sandboxed environment which is able to run our code. So we need a runtime, and that runtime is optimized for stateless transient compute, which means as soon as somebody triggers our function, there will be a runtime available for us. And then maybe after our function is done, it will still be there. We don't know, right? So it might be destroyed. It might still be there, so when we hit it a second time, right, we don't have any startup costs or whatever. We have no clue, right? We only know that there will be a runtime provided for us, but we should not try and optimize for that runtime, because as soon as you start doing so, then a week from now, the underlying implementation may have changed, and we are optimizing for the wrong things, right? So never try and optimize for the underlying runtime. You might say, well, this sounds awfully familiar, right? We've heard this message a couple years before, right? When we were talking about platform as a service, as an added layer of value on top of infrastructure as a service, right? So it's actually new, right? This sounds just like PaaS. Well, there's a bunch of differences between platform as a service and functions as a service. First off, with platform as a service, like Heroku or Google App Engine, for example, we're still managing applications, right? So somehow we're building something like a web application, we are creating like a big WAR file, and we are deploying that WAR file onto some sort of a web server, right? And then we add a bunch of libraries, etc., etc. So we're still building applications. Because we're building applications, we have a clue about the underlying runtime. We need an application server running underneath, right? Which could be a web container, could be something else. With PaaS, we therefore also take care of scaling, right? We need to determine when we deploy our application whether it needs a big server or a small one, and whether or not we need to scale up, right? Whether or not we need a couple instances on cold or hot standby, so that as soon as people are, picking up on our application, right, and the load increases, that we are still able to cope with that load, right? So we take care of scaling, and therefore we need to provision enough applications on enough servers, right? Therefore, we also need to manage our own runtime environment, right? We need to take care of handling logging, configuration, whatever, right? And then, because we need to manage all of this, right, we also pay for all of that, right? So we pay for all of the server instances that we use. And it makes a difference whether we pick a small server or whether we pick a big server, right? It makes a difference if we have like 10 instances on cold standby or 10 instances on hot standby, right? So with functions, we have neither of those things. So no clue about servers, no clue about handling the configuration of those servers, no clue about configuring scaling, and we don't pay for all of those things. And we also have no clue about applications anymore. We talk about individual functions. And this is both a pro and a con, as we will see later on. So to summarize this, we can create a picture like this. I think the other day I saw Arun Gupta explain this. So I asked Arun, can I borrow your slide? And he was okay with it. So if you go from left to right, we see the type of services that your typical cloud provider offers these days, right? And we go from pure infrastructure as a service, where most of the things that we run on top of our virtualized hardware is being run by ourselves and being taken care of by ourselves. And then if you go to the right, you'll see we have containers as a service, where we just add another layer of abstraction. And then with PaaS, we just add another layer of abstraction, or actually two. And then with functions, the only thing that we are taking care of ourselves is the actual little piece of code that we create and deploy, right? So coming from the left-hand side, going to the right-hand side, there's less stuff that we have to configure and take care of, and there's also less stuff that we pay for. Now there's a whole lot of serverless implementations out there. So I just listed the big four here. I think it's fair to say that Amazon kind of invented this, right? So they came up with Amazon Lambda, AWS Lambda, back in 2014. That was when Werner Vogels coined his quote that I mentioned earlier. And then as you can see, there's a bunch of other vendors like Google, who came about a year after they had their Google Cloud Functions available. I think that's only able to run JavaScript. And then IBM and also Microsoft came with serverless implementations. So there's a whole bunch of them available. And even Microsoft announced a couple of weeks ago that you're able to run Java on their Azure Functions implementation. So that's actually pretty cool. Another thing that was introduced a couple of weeks ago is Project FN by Oracle. I don't know if you heard about it. It was announced at Java 1. It's also an interesting take to serverless, because they're not just implementing the serverless manifesto, but they're also challenging some of the things in the serverless manifesto, like how to deal with state and how to deal with flow across functions. We'll talk about that later on, and if we have enough time, I'll show you a bunch of demos with FN as well. But if you're interested, go check it out. So for the remainder of this talk, or actually for a large part of this talk, I will focus on the features of AWS Lambda. It's not because I work for Amazon or anything, but because it's very accessible technology. I don't know if you already have signed up for a free Amazon account, but if you do, you can get started with Lambdas within a couple minutes. So if you brought your laptop, you'll be able to deploy your first bunch of functions by the end of this talk, or maybe even sooner, right? And well, I think it's fair to say that right now, if you look in terms of features, etc., they're actually the front runner in terms of serverless, right? But the others are catching up. So maybe if we do this talk in about a year from now, it might be the other way around. But for now, I think they're still the front runner. All right, so about AWS Lambda. It's introduced as a serverless, event-driven compute platform provided by Amazon Web Services, right? So it runs your code, so a piece of code, in response to triggers or events. So it's heavily event-based. It was introduced about 3 years ago at that same reInvent conference that I talked about before. And it's part of the many offerings that Amazons have. So if you, this screenshot's actually from maybe a couple months ago, and there's a lot of services that they offer, right? And so Lambda is just one of it, right? So it's up there in the top left corner. It's one of their compute services, actually, right? So there's a bunch of compute services out there, so maybe it's good to compare them, right? So you have a clue what we're talking about. So Amazon offers you a couple of compute services. First one is EC2, which is basically their infrastructure as a service offering. This is actually pads. This is servers, right? So we have a server. It's going to be small, medium, large, extra large, whatever. And then on top of that, you manage everything. You manage the operating system, configuration, runtimes, application server, whatever. It's all up to you. Alternatively, we have EC2 container service, which is basically the same, but then you feed it a Docker file, right? So you say, well, I have a Docker file which describes my runtime environment and all of my configuration issues, right? And all of my dependencies. So I just feed it the Docker file and then I instantiate a server based on that Docker file. Then we have something called Elastic Beanstalk, which is a funny name, but it's, well, Amazon is actually known for funny names for all of their services. So for most of the services, you have no clue what it actually does, just from the name, right? But Elastic Beanstalk is basically their PaaS. So it's like a web container and then some, right? So it's like a platform as a service offering, which is able to run applications, and you can compare it to what Heroku is doing, what Google App Engine is doing, and a couple other implementations as well. And then finally, we have Lambda, and Lambda is their functions as a service offering. In terms of runtime support, they have support for 4 languages, basically. So you can run Python or Node. I think they support multiple versions of Node, actually. So in this case, this is in interpreted languages, on the fly, right? So you can even just launch their web console. You can start typing your code right away, save it, configure it, and you're done, right? But if you do Java or C#, then you mostly edit your code offline. Then you zip it up, you upload it to the cloud, and then you define a trigger for it, and that's how it works. Right? So as you can see, they only have support for one real programming language, which happens to be Java, of course. All right, so how it works, and I'll show that to you when we do a couple demos later on. You just create your code in your favorite IDE or in VI or whatever, right? You just create your code and then you create like a zip file deployment of your function. You upload that zip file to, in Amazon's case, to something called S3, which is their bucket store, right? So you just upload a zip file into the cloud and it just sits put, right? Does nothing. Then you go to a console, or you can use the command line interface in order to configure a trigger for your code. So you say, well, when somebody does a database insert on this table, right, then I want my code to run. Or you can say, when somebody does a HTTP call to this endpoint, I want this code to run. And then you hook up that trigger to your code, right? So you define which class to instantiate. And then you wait. You wait till somebody actually triggers your code. So in this case, you do like a curl to HTTP endpoint, for example, if you hook it up to that. And that will actually trigger an instance of your code, an instance of your function to run. So Amazon will run it, they will meter it, and then you pay for the amount of seconds and the amount of memory that actually used, right? And so they have like a small calculation that they use in order to determine the amount of money. And then when your code is done running, they send you a bill. Well, basically they do it once every month, but this is how it works, right? In between, when nobody hits anything of your triggers, right, you don't pay anything, right? So you only pay when people actually run your code. So trigger and run your code, and you pay for the actual runtime, right? So if it runs in like 5 milliseconds, you only pay for, they round it up to the nearest 100 milliseconds. So you only pay for 100 milliseconds. If it runs for 5 seconds, well, you pay for 5 seconds, right? Sounds like a fair deal, right? Pay for use. All right, so let's start building our first Lambdas. Right. So how do we do that? So there's a couple ways to get started. First thing, we need to sign up for a free AWS account, right? And then we get our first 1 million Lambdas for free per month, actually, right? So that sounds like a good deal. And the other thing what you can do is you can install the AWS plugin for Eclipse if you happen to like Eclipse. If you don't, then there's also Maven plugins available, and I think for IntelliJ there's also a plugin available that you can use to interact with the AWS command line interface in order to create packages and upload stuff into the cloud and do your configuration. And then we can write a piece of code, and when we're done, we can either use the plugin or use the command line to upload the code into the cloud. That's exactly what we will be doing next. All right, so for this, I'm first going to show you. I'm going to the editor straight away. So I just have Eclipse installed here with the AWS toolkit because it's great for demo purposes. So what I can do is I can create a new AWS Lambda Java project. All right, let's call it Hello Devoxx, and let's configure the input event. So because it's a function, it needs input, right? So let's set it to custom, so we can edit that later. And then I'm just going to finish the wizard. So I get like a README that shows me what steps to take. I'll skip that for now. And then it generates a little bit of code for me. So what I'm going to do here is I'm going to set the input to be a string. And I need to set it here as well. And then the output is also going to be a string, right? So function, string as input, string as output. And then what we're going to do is write an actual hello world implementation. It's a little bit hard to type at this angle, but let's do your typical hello world where we say, well, let's do hello plus input. All right, very simple function. Now if I save this, then something will show up in my problems view because the wizard also generated a unit test using the same scaffolding template, so I need to fix it. So in this case, the input is going to be a string. Right, so the nice thing about the plugin is you get the implementation class, you get a unit test for free, right? So they thought about that too. And so we can set input. So let's say, well, let's set the input. Oops. Set the input to Devoxx. And then let's do an assert here, where we say, well, the input should be the same as this, and then hopefully we save. We'll compile, and then we can run it. We can say, well, run as unit test, and we have a green bar, right? So it's nice. It's just a simple POJO, right? So that makes it easy to unit test. It's a function, right? So it's just small implementation, and because it's small, it's easy to test. Now, of course, this is not running serverless yet because it's not running in the cloud, it's running locally on my laptop. So the next thing to do is basically run this in the cloud. So I can use the same wizard where I say, well, run this function on AWS Lambda. It says, well, you need to upload it first. So I say, well, upload now. And what it does is it asks me to which AWS region I want to deploy. So my stuff is running in EU West in Ireland. And then I can create a new function or choose to update an existing function. So in this case, I create a new one. So let's call it Hello Devoxx. Press next to just give it a meaningful description, right? Like we always do. And then it asks me to define a function role. Now the thing with Amazon is that they have very fine-grained authentication authorization models for their infrastructural stuff. So every time you need to run something on something, or something needs to use something else, you need to have permissions for that. So in this case, I just set up a very simple role that has access to run a Lambda and to access the log and metrics. Right? So I don't want to bore you with this, so I set it up beforehand. It's nothing special, but just so you know. Next thing it says, well, I'm going to upload this zip file, which I will be creating behind the scenes, into an S3 bucket. And S3 is just their object store, right? So it creates a zip file, upload it, and it will sit there. So I point it to the right store. And then I need to configure a little bit of memory settings. And this is not because we're actually configuring the underlying server, but this is because we want to configure the amount of money that we want to pay, right? So this is a very simple implementation, so I probably don't need half a gig of memory for it, right? Let's start with 128 something, and then the runtime, let's set it to maybe 2 seconds or something, right? Or 3, whatever you want to do. And this is the amount of time after which the function will be cut off. So if it runs longer than 2 seconds, the runtime will just shut it, right? So this prevents me from paying for a function which runs endlessly, right? So we set a hard limit on the amount of time it is allowed to run. So this is basically configuring costs, not so much configuring the server. So now I press finish, and hopefully the Wi-Fi is a little bit reliable. So we're creating a zip file, uploading it into the cloud. Okay, everybody get off the Wi-Fi, please. Yep, there we go. And now it's in the cloud. You have to believe me, I'll show it to you in a minute. So now we can just repeat the run function on AWS Lambda. And now we can configure some input. So it takes a string for input, so we can say, well, let's say Devoxx 2017. And then invoke it. And now in my console, you can actually see it's invoking the function, it's sending the input into the cloud, and then we get a little bit of logging, and also a little bit of metrics as well, where we say, well, we see a start event because somebody is triggering this function, right? Then we see some input. This is basically the console.log, which you saw in the implementation. And then at the end, you get a little bit of metrics in terms of the amount of time that it took to run. And then you see it's rounded off to the nearest 100 milliseconds. The memory size that I configured, and then the actual amount of memory that it used. So now the interesting thing is I run this again. You'll see it's much faster. Right? This is because it's Java, right? So it needs to fire up JVM. It needs to load some classes, and that takes a little bit of time. So the first time that you run this, you actually pay a small penalty for this to run. Also, not only in terms of time, but also in terms of money. Right? So, funny thing is, do we need to optimize for this? Right? So, do we need to warm up our servers as soon as we deploy our application? Well, the answer is no, you should not, because then you try to optimize against the underlying implementation platform, which you have no clue of. Right? So, if there will be enough users using this, it will be fast enough eventually, when everything is warmed up by your users. Right. If you use another language, like Node.js or like Python, right, you don't pay this penalty. So you'll see that it's much faster. It will only take like 2 or 3 milliseconds for this to run. And that's also because a lot of the external dependencies that you need to use are already supplied by the platform. So you don't need to load the classes for it. All right, so now you've seen it run. Now let's switch to the browser for a second. And what I'm showing you here is actually Amazon's Lambda management console. So if you sign in using your account, you can open up the Lambda console, and this gives you a list of functions. So if I refresh this, then we'll see that there's like a hello Devoxx here, right? And it points to a zip file in S3, which I can show you. But it has the configuration for the role, it has the configuration for the memory and the timeout setting, and a description, very meaningful. And then the handler, which it will bootstrap. So basically it's like a servlet maybe, right? So you need to point to a method that will be invoked using the input and where you get the output from. Second tab over here is called triggers. And now triggers is what we actually use to trigger our function, right? So far we just uploaded something into the cloud, done nothing. So there's no way for other people to basically trigger this function. So in this case, we can define a trigger, which I will do later on. And then we can start triggering our code. But then before we do so, I just want to show you the third tab, which is called monitoring. And this is where we get some basic metering, right? Where we can say, well, there's an invocation count. It was invoked 2 times by now. We see the duration, we see whether there were errors, etc., etc. Right? So you get a little bit of metrics out of the box. And then logs are centralized as well. So we can say view logs in CloudWatch, which is Amazon's service for viewing your logs. right? So we can open up the output, and this is where we can see the logs which were shown earlier in the Eclipse console. Now about those triggers. Let's create a trigger. So using the CloudWatch servers, I can also set like a scheduled trigger. So for this, I'm going to say, well, let's create a new rule. Let's create a rule. Let's make it a scheduled trigger. And so let's set it to a fixed rate of 1 minute. And then every minute, I want to trigger a function. So let's trigger the hello Devoxx function. Give it some input. All right, so you can give it a constant, for example. Well, what are you going to do? Devoxx again, a little bit boring, but configure details. You have to give it a name. Let's call it fire once per minute, and then a meaningful description again. Right? We enable it by default. Let's say create rule. And now we have a rule which will basically trigger our function once every minute. So if we go back to the Lambda dashboard and I go back to triggers for this function, we now see that we have a trigger defined. So Amazon will take care of this. So if we wait long enough, eventually something will show up in the log. So let's see, it wasn't triggered. Have to be patient. Hard to read. Or I can show you the logs as well. Maybe let's just start watching at the logs. Now it's still, those are still the, oh, there it is, right? So you just saw it triggered. So once every minute it will trigger this function, and now we have a trigger defined. So this is pretty meaningless trigger, but the trigger could also be like an HTTP REST call, or it could be like a database insert or whatever, right? And I'll show you more useful examples later on. Yeah, I think for now that's good. Let's switch back to the slides. So about triggers. Lambdas are event driven, right? So meaning we have to wire up triggers to our functions, otherwise they can't get called. Now Amazon has a lot of event sources that we can use as triggers, right? And if you're familiar with the Amazon services, then these will be meaningful. If you're not, then I'll try to do a quick translation of it. So basically what Amazon does is they support HTTP requests. So you can define like a REST API or CRUD API on top of your functions, right? And then wire the individual operations to different functions. Or you can wire CRUD events on data sources to your functions, right? So if somebody does an insert or a delete from a database, that could be an event to trigger a Lambda function, right? And you can do something meaningful with that data, for example. Or you can hook it up to some sort of messaging service that Amazon provides, and they provide a number of them. So they have like a simple in-memory messaging service. They also have more elaborate messaging services. They have email services, so somebody can send an email to a certain account, and that might trigger a Lambda service, right? So could be meaningful implementation to do some sort of customer service thing. On the right-hand side, we see that we have support for log and stream processing, which you can use to do, well, to process big amounts of data. So, for example, we can hook up our functions to maybe the Twitter fire hose or something using Amazon's Kinesis or whatever service, right? Or we can start processing the logs of other Lambda functions, right, by giving it access to the log files and then process everything that gets written in the logs. Or we can hook it up to more developer services, like, for example, Amazon's implementations of Git, right? So if somebody commits something into a repository, then we might trigger maybe a custom build loop, right? So we can use Lambdas to build like a CI/CD pipeline, right? And using a commit hook, we can trigger the first Lambda to run, produce something which then will then trigger another Lambda to run, etc., etc. Same thing can be done for configuration management services. So if somebody rolls out new templates to create servers or to or creates new users in a IAM kind of store, right? You can all just respond to those kind of events by triggering Lambdas using those events. And then the funny one is using Amazon's services for interpreting text and voice. We can also hook Lambdas up to voice commands, or maybe to a chatbot, right? Which is also very cool, and I'll demo that later on. So now that we know a little bit about how Lambdas and functions in general work on a serverless platform, or just on one of them, I'll show you others later on, let's try and rethink the traditional architectural concept. So would it be possible to replace everything that we've built before using this kind of technology, right? Just think hammer and nails again, right? So how do we do this? Let's imagine the typical web application for a second, right? So we have like a 3 or multi-tier application that has a database for storing data. On the right-hand side has some form of a web application running server-side, right? Whether that's like a HTML generating server-side framework, or whether that's just a bunch of REST services, that doesn't really matter. And then we have some form of a client, which could be a browser, but it could also be a mobile application, of course. Right? So this is a typical web application nowadays. So would it be possible to reimagine this concept using a pure function approach, or using a pure serverless approach? Well, the answer is yes, it's possible, but it's a little bit more elaborate. So I'll talk you through it. So first off, we need to figure out a way to actually distribute the static logic. So for example, if you have a web application, then the browser needs to download your HTML, CSS, JavaScript from somewhere, right? Now for this, we can use either a content delivery network, where we have those files available, just static compiled files, right? Or we can use, in Amazon's case, we can also use S3, which has the option of hosting one of its buckets as a static website. So as long as the content is static, so if it's like an Angular application which is transpiled, JavaScript, HTML, CSS, images, whatever, you're fine. You just host it in an S3 bucket, and then you make it available as a static website. So then you can hook up a domain name to it, and then your clients, your browsers, can then actually download the content from there. Instead of having a static website, it could also be a mobile application. In that case, the mobile application is being hosted in the App Store or in the Play Store, and you can just download the mobile application to your device, and that's how you distribute the client side of things. So the second step would be to have some sort of a third-party authentication service, right? So you probably integrate with something like OAuth or something similar, or you hook up to a Gmail or Facebook or whatever you use as an authentication mechanism in order to gain access to the application or certain services of the application. Then we need to get some content into the application. For this, you can use one of the databases that some cloud providers offer, because you just dump in a little bit of data, let's say product data, and then you make a piece of your catalog available as read-only data. So your mobile application or your client can actually go to that catalog directly and use that as its data source. Right? You have some form of a CRUD API in front of, or in this case just a read option, so you have some form of an API in front of it, so you can download the data into your mobile app or into your browser. Right? And because it is read-only, there's nothing bad with sharing it directly from a catalog. Then some of the logic which used to be on the server needs to go to the client. Right, so a little bit of the MVC style logic that we have. So in the old days, your server-side web application basically was your controller. So you use it to navigate from screen to screen to screen, and then it also knew where to get the data from. Now, in the newer style web application that we built for the last couple of years, we move at least part of that logic into the client as well. So if you use Angular or something similar, right, then we have a model view controller alike mechanism within your front end. Right? So some of the logic that used to be on the server will now be pushed out to the client. If you build a mobile application, you already have that logic in the client. Then, if there's additional functionality that we need to invoke, right, we need to make that available through some sort of a gateway. So in this case, eventually we'll keep some of the logic in functions, in Lambda functions, but in order to reach those Lambda functions, we have to make them available to the outside world. And for this, we will use something which is now called an API gateway. An API gateway is what you use to define a maybe CRUD-style REST interface, which can be versioned, which can be documented with examples as well. So your mobile client, or your browser in this case, is able to invoke it. And since it's REST, it will play nice with either mobile applications or with Angular-style applications, for example. Now, API gateways are services being offered by cloud providers these days. There's also a lot of old-fashioned ESB products which are nowadays dubbed API gateway, right? So if you want to spend the money again, buy an API gateway. And then finally, when we have a piece of advanced functionality, right, we can keep that kind of functionality on the server. It saves you from updating your client every now and then. It saves you from adding a lot of logic in the client. And some form of functionality is probably not suited to share with your client, right? So you keep it on the server. So in this case, let's say it's advanced search functionality. And using this function, we can trigger this function via the API gateway. So somebody just issues a GET or POST or whatever on a REST API. That will be the trigger for our Lambda function to run. And that Lambda function can then basically use the same data set on the server in order to do some interesting sorting stuff. And then it will respond through the API gateway. And using the API gateway, just as with an ESB, we also have the option to remodel that data, right? To convert it to something else or do some interesting things with status codes or whatever. And then finally, we have some piece of functionality which is best suited just to stay on the server, in this case, purchase functionality, which will walk you to the purchase process and eventually will save an order in a purchase database, right? So the answer is yes. In a pure serverless world, we can still build web applications. Warning here, of course, is just because we can might not always be the right reason, right? So I'm not trying to encourage you to go back to work tomorrow or Monday and then start converting all your web applications into Lambdas, right? It would be cool for a day or two, but then probably not such a good idea. So let's think of a couple reasons where serverless might be a better fit. Oh, something that I should add here is that, as you've seen in my previous example, serverless is more than just functions as a service. Now, a lot of people these days, especially on Twitter, etc., are talking about serverless as if it is just functions as a service. But as you could see in the previous example, we were using a combination of both functions, Lambda in this case, and also other serverless implementations, be it a database, being it a API gateway, a content delivery network, static website hosting. You could all consider them as serverless implementations too. Because as a developer, right, you just use the functionality, you do a little bit of configuration, but you're not dealing with configuring the underlying servers or the underlying runtime for those services. So serverless is actually way more than just functions. All right, now let's look at better examples instead of rebuilding all our web applications using functions. All right. So prime example for this is what they call event-based processing. Right? That's what we've been talking about before. So a thing that you can do is, for example, you can respond to incoming data. So if somebody uses your application and then needs to create some data, in this case, your new user needs to create a user profile, then as soon as the user is sending you data in terms of either profile data or in terms of a profile picture, right, you can respond to that incoming data and then do some back-end processing. The interesting thing about this is that this is pretty unpredictable logic in terms of unpredictable when it will run, right? So when you launch a new application in beta first, you just have a small couple users using your functionality. So it's really handy to have something that will just only work when triggered, right? So you don't have to set up a complete backend application on top of a web server. You need to think about scaling. So if I'm dealing with 10 signups, at a second, can I also get away with like 100 signups when I get really popular? And how about 1,000, etc., right? So this piece of functionality is actually really interesting to build as serverless. And you can use it actually for small amounts of data, but also for batch data processing. So what we will be doing is, let's imagine we have an application. Once again, could be website, could be a mobile application. that asks you to create a new profile. And then during the profile creation process, it asks you to take a picture of yourself and then upload that picture into the cloud. In this case, it will upload that picture into a S3 bucket store, which is Amazon's object database. And then that object insert, or the put of that object into the bucket, will trigger a Lambda, which will then process the incoming image and create a thumbnail out of it. And then it will place a thumbnail into another bucket, which can then be processed by something else, right? Or maybe the bucket is just a place where all the thumbnail images reside, so you can use it to link using a HTTP request, whatever. So for this we will use S3. I said enough about S3, I guess. So let's show you a little bit of code. So for this I have a pre-cooked demo. Let's go to the implementation. So what I have here is something called a S3 event handler. I'll make it a little bit bigger so you can see. So once again, this is just a simple handle request method that we're implementing. So just a simple Lambda. And the Lambda gets input in the form of a so-called S3 event, which is something the Amazon runtime creates as soon as somebody does an insert. I'll use that insert as a trigger for my function. So I get an S3 event as input, and then I'll send some string as output, maybe a status control message or whatever. As soon as somebody will trigger this function, do a little bit of logging, and then the interesting part begins here, where I'll say, well, let's look at the incoming event and retrieve the bucket and the key combination. Because in S3, a bucket and a key combination will point you to a record in the database, like a primary key for something which resides in S3. So I figure that out. And then I will use a Amazon S3 client, right, to actually connect to S3 and then get the actual object. So I now know which object to get. So I get the object, and from the object, I will start reading the metadata, and then specifically, I'll try to access the content type, right? Because I want to check whether the content type of that image is of type image/JPEG. So then I can process the image. So this function only implements this, right? And then I do a little bit of image IO magic here. Just a fairly straightforward, simple implementation to read in the original image and then compress it into a 100 by 100 thumbnail image, right? Not really fancy algorithm, just the most straightforward way I can actually think of. And then, if I'm done creating that thumbnail, I'll create a new file, right? I'll give it a file name, and then I do some conversion with byte array. So I get an array of bytes which I can then write to a file. So I'm going to insert the new object into another S3 bucket, which holds all the thumbnails, right? And then finally, I'm going to write that image into that second bucket, and if I'm done writing, I will delete the actual incoming object, because with S3 you will eventually start paying for the amount of data that you store. So in order to keep my bill limited, I just throw away the incoming data if I no longer use it, right? Although there's like a big free threshold, but eventually you start paying. And then I'll just return done when I'm done. Okay, so this is basically all the code that I have. Now to save time, I've already uploaded this code into the cloud. So let's go to the Lambda dashboard. And then look at my functions. So there's an S3 event handler over here. And this event handler has a trigger defined, which is of type S3, and then of event type object created. So if somebody inserts an object, then my Lambda will be notified. So it's enabled, so it's active. So now let's go to the S3 management console, right, which will list all of my S3 buckets. And then I have a incoming bucket which I have called incoming files for Lambda, which is empty now. I can refresh it. There's nothing up my sleeves, right? And then I can upload an image there. So let's go to desktop and find a suitable image. So I have an image here of a little Java Lego thingy. So I'll upload that. Upload it into S3. Takes a little bit of time. Now you see it's in there. And now if we wait for a bit, hopefully it will disappear, right? That will be a good sign. Stuff disappearing, in this case, is a good sign. Since it's the cloud, it's eventually consistent, so I need to help it a little bit here. Right, so now it's gone, so that's a good sign. And then hopefully, in the processed image thumbnails folder, I have the Hulk thumbnail. Yep, there it is. I just created, right? So then I can open it up, and we see that we actually have a 100 by 100 pixel thumbnail here. Okay. So then let's head back to the Lambda console. Let's go to monitoring. See that was invoked. So let's go and view the logs. You see that I've been running this demo a couple times before. And here's the output logging. Right? Not sure if you're able to read it, but so we see that we get an input event with event name object created put. Then we see the raw key name, right? We fetch the image from the bucket, figure out what the content type is, then we do the conversion thing, and then it's done running. As you can see, it took quite a while to run because it needs to warm up some stuff. If I run it again, it will be about 1 or 2 seconds maybe. This is also because I used a very stupid implementation of the compressing algorithm. So if I optimize on the algorithm, it will be much, much faster. All right. What more is there to show? I think for now we're all right. So maybe this is a good time to do a coffee break. And then, you just arrived here, okay. Well, good time for coffee. Let's do a quick coffee break. I'll see you back in 15 minutes. And then I'm going to show you how to build microservices in the cloud, right? All right, so we're back up. I hope we didn't lose much people. There's a few of them, still people coming in. Okay, so let's continue. So, summary so far for the two of you that were just here for the break is what we've seen so far is just triggers, right? We've seen triggers again. So somebody reinvented database triggers. Hoorah. All right, so can we actually do any more interesting stuff with this just besides database triggers all over the cloud? Well, I think so. So a next example is going to be, well, going back to the whole backend as a service thing, right? So actually I think this is interesting in terms of mobile applications. Because imagine you're a mobile developer and you're really good at developing the app side of things. For some pieces of functionality, you want stuff to run on the server. But what you don't want is to become responsible for setting up servers in the cloud, for actually managing those servers, for scaling them yourselves, etc., etc., etc. Right? This is a whole lot of work, and you have to pay for all the stuff too. You have to think about scaling again, etc. So, using Lambdas or similar implementations at other cloud providers as backend as a service implementation is actually a pretty interesting idea, right? So in this case, what you probably do is you have a piece of functionality or more of those pieces running in the cloud, right? You just create the code, and maybe you can even create it using the language of your choice. So if you're an iOS developer and you like building your application with Swift, then if you use IBM's OpenWhisk implementation, or OpenWhisk in general, it's an open source project, then that has bindings for Swift too, right? So you can write your backend logic in Swift too, and then deploy that into the cloud, and then just define a trigger. Now this trigger is probably going to be an intermediate layer which understands CRUD-like operations. So this is where we run into the API gateway again. So just to depict it into a scenario, we can either have like a mobile application or have like a web application again. That doesn't really make a difference. That uses Angular or some web-style mobile framework or a native mobile application that knows how to talk to a REST endpoint, which is defined on a API gateway. And this API gateway has then a trigger to a Lambda function, which does something interesting and then finally persists something in a database. In this case, instead of choosing S3, I chose DynamoDB, which is just another database that Amazon offers, right? Just for fun. So when we start doing this, we immediately stumble upon this intermediate component, which is the API gateway. Now in this case, if you look at the API gateway through the eyes of the web console, it looks as a very simple thing. But the API gateway is not. It's actually a very complicated beast. There's lots of stuff which you can configure. And basically figuring out the API gateway is what took me the longest time in terms of experimenting with all of this. Now, luckily, there's a bit of wizards and shortcuts that you can take, which I will show you. So that saves you a bit of time. The other cool thing about this API gateway is that it's sophisticated, right? So it's also sophisticated in terms that it knows how to deal with versions. So you can have multiple versions in operation at the same time. It knows about stages, so we can run development stuff apart from running production stuff. And it has good support for contracts and documentation. So if you're used to writing Swagger documents or Swagger contracts, then the API gateway supports those contracts. So you can upload your API contract into the API gateway, or you can generate documentation from it. So that's actually pretty cool stuff. So let's do another demo. So in this case, I'm gonna be using a mobile application. Let's switch to Eclipse for a minute. So I built a tiny application, and I'm not really good at front-end stuff, as you'll see in a minute. But I have like this static HTML file. I included jQuery just to annoy you, right? Just on purpose, right? So it's static HTML, a little bit of CSS, a little bit of images, and then a bunch of JavaScript, which I put in the same file, of course, right? So basically what this does is actually create some JSON package, that upload it to a CRUD API in the backend, and then show the result. That's basically what this does. Now let me show it to you. Right. So here it is. Unfortunately, it's in Dutch. I didn't have time to translate it into English, but it's actually pretty easy to understand. So what this does is, I'm a big fan of cars. In this case, I drive a company car, a lease car, right? So I want to figure out if when I start a new term or new contract for my lease car, whether or not I will end the contract before the term. So if I lease like in a 4-year contract, I want to figure out if I've driven enough to maybe return the car after 3 years or so, right? So I built a small application for this like 10 years ago. And now basically what I can do is I can say, well, let's say I have I lease a car somewhere in, let's say 2015 or so. I started a contract which ran for 48 months, right? So that's in the terms of the contract. Then the mileage on this is like 140k in kilometers. So if I either cross the amount of mileage, right, then the car needs to be returned. And then I have like a current situation. Let's say I've driven only 50k kilometers. 50k. Right, and now I can check. Hopefully it works. Oops, it doesn't work. Let's try it again. Maybe I need to reload. Ah, there it was. Something went wrong. So 48 months, 140k kilometers, and then if I've only driven 50k, let's check. Oh, maybe I run into a cross-site thingy here. Let's see. Disable restrictions. Let's load it again. I switched network, so then it might run into a cross-site thing again. So, trying to bore you with this again. So a little bit of input. 140k and then 50,000. Now, hopefully it works. Take a little bit long. Ah, there it is. All right, so you also see my amazing user interface skills. Right, so I now get a little bit of information back from the backend. So it says, well, start a contract. If everything goes according to plan, right, you lease your car for 4 years. So then you should return the car on November 7th, right? Current date is November 7th in 2017. So you're 2 years in. So you're so the amount of time that has passed is now 50% of your contract, right? If you want to return the car exactly by the terms in the contract, you need to drive at least 95 kilometers per day. Your actual kilometers per day are only 68. So I don't expect this contract to end before the actual terms of the contract, right? And then, but if you do, but when it ends after 4 years, I expect that you've driven about 100k kilometers, which makes the average per year about 25k, right? So this is just very straightforward stuff. So I've shown you the front end. So the front end could be an app, could be some static thing. In my case, it's a static thing. And I'm actually hosting this static thing in S3. So if I'm going back to the front end implementation, going to S3 here, I have a bucket called Looptijd app. And within this bucket, there's all the static stuff in there. And then if I go to properties, I guess, I configured that I want this bucket to be a static website, right? So you just upload the stuff, you just enable this feature, and now it's just hosting this as if it was like a website. So if you look at the URL, you see that it has like an S3 bucket name in there. But what you can do is, using Amazon's Route 53 service, you can hook up a domain name to this bucket, and now it just behaves like a regular website. So it's serverless, right? I don't take care of servers, I just throw in a bunch of static stuff, and now I have a client-side application. But this could also be a mobile application. Now let's go to the back-end side of things. So I switch back to Eclipse. Now I'm almost ashamed to show you this logic, because this is something that I've written a long time ago, I think over 10 years ago. So I just took the old implementation, which was a POJO, and which is basically just one function, predict end of contract. I get a little bit of contract data as input, and I'll return a result. So you can see it's old stuff because it uses calendar to actually deal with dates, right? So I probably could have used like maybe 60 lines of code less if I use the new date and time API. But apparently this is just old stuff. It works. So I just took an existing POJO and I recreated a Lambda out of it. So I did this by wrapping this POJO in a handler, right, which got then the contract data as input and a result as output. So, and the only thing I do is I invoke the function. Now the contract data object is this one. This is a POJO. Nothing special about this. And the cool thing about Lambda is that AWS will automatically map incoming JSON data to this object, right? So underwater, probably use Jackson for this. And if you're not satisfied with this, you can do the mapping yourself as well. But I'm using the automatic mapping. And the same thing for the result object. So if you look at the result object, it's just a POJO again with a number of fields, which I then fill out and then send back to the client. So I zip this up, upload this into the cloud, which I've done already. And then if I go to the Lambda dashboard and I go to functions again, there's my Looptijd calculator Lambda, which contains a zip file, a little bit of configuration, a little bit of memory, a little bit of seconds to run. And then I define a trigger. And the trigger in this case is the API gateway. So I'm using an API defined in the API gateway to actually trigger this. So to be more specific, I'm using a post on my Lambda. So if somebody posts some input data, it will trigger the Lambda. So let's go to the API gateway to show you the definition of this. Just refresh it for a second. So here's my API called Looptijd Lambda. And then there's the post operation over here, which will then be visualized by the editor. And then you see there's like a client that sends an incoming request, which is then going to be mapped using an integration request to a Lambda. The Lambda is over here on the right-hand side. So this is my Lambda. If I click on it, I go back to the Lambda dashboard. And then the end result of the Lambda is then mapped back to an integration response, which is just a pass-through to the method response, which will then be an HTTP status 200, and it will then be sent back to the client. Now, this is a very simple REST API, but it does support staging, so I can deploy it to either dev or production or whatever. It supports versioning, etc., and also supports testing. So in this case, I can say test, and then I have a little bit of input data pre-configured. So in this case, a little bit of JSON. I can input that JSON over here. I can press the test button. Then I will run and I get my end result back. You see it's pretty fast, just a couple milliseconds. Right, so this is a nice way of just doing a quick smoke test here. And then of course there's there's logging and other interaction going on. So you see invocations, and once again we can go to CloudWatch to monitor the logs. Then we see some incoming data and some outputs that I wrote, either using the logger or system out, doesn't really matter. I just send it to the output, and then Amazon will collect all of those logs for you and present it through CloudWatch. You have to take care though, if you use system out a lot, then it gives you a little bit of an I/O penalty, right? So you should actually use the logger. All right. So this is another way of actually using serverless in order to provide some useful functionality. And actually, if you want to see this in action, you can just take your phone out and go to the My Devoxx app, which you probably all use, right, to schedule your sessions. And then underneath the My Devoxx app is also a lot of serverless functionality, right? So in terms of coding everything in the app, like they used to do in the years before, they now decided to move bits and pieces of that functionality into the cloud. So this gives you a number of advantages. First, if there's actually an update at that functionality, so if you fix some of the functionality or you add more functionality, in the backend part, you don't have to update your mobile app, right? So you don't have to go through the whole process of updating it, submitting it through the App Store update process, etc., because your logic is in the backend, right? And secondly, there's going to be less code in the mobile app, which is also good, right? And you have more control over the backend, and you only pay for actual usage. So it's actually a pretty cool model. So let's get back and let's revisit this scenario, right? So what I just did is we have a client, we do a call through an API gateway where we define an API or a contract for our Lambda, then we hook that up to our Lambda. Now, interesting question that I get a lot is this Lambda now a microservice? Right? Interesting question. And I think the answer, like a true architect, it depends, right? So are Lambda functions microservices? Well, first off, there's a lot of similarities between them, right? So they both do one thing and one thing well, which is kind of like the definition of a microservice. And then this whole thing is being triggered by events. So there's event-based interaction, which is like choreography, and this is a model that microservices tend to like. Right? So yes, there's similarities. Then there's also differences. Differences in terms of granularity. Because one Lambda, in this case, is equal to one action. And in the case of microservices, that might not be enough, right? So you might have, if you want to do microservices that CRUD-based operations, you probably need 4 or 5 Lambdas to do the same thing, right? So you separate everything out into functions. So in this case, the Lambda will be smaller than a microservice. So let's call it a nano service or whatever, pico service, up to you, right? So in my opinion, a microservice is a bounded context of actions and a little bit of domain with autonomous storage, right? And so the storage and the bounded context and the actions are not part of a single Lambda service. So in some particular cases, one Lambda might be a microservice, or could be a microservice, but in most cases, I think you need more Lambda operations to actually build a microservice. So you'll probably build something like this, right? So you have your clients, left-hand side, then you have something in the middle, the API gateway that defines the interface, or the CRUD API, and then the operations of that API, of that contract, will be mapped to several Lambda functions. And they all have interactions with the same database or data store. So in this case, I would say that the entirety of this would make up the microservice, right? The contract, the mapping to Lambdas, the mapping from Lambdas to the database, and the database itself is also part of the microservice, right? Because in a microservices world, the microservice owns the data store, right? Owns the database. Nobody else is allowed to touch it. Well, if you must, for read-only maybe, but not for writing or updating data to it. Right? So this would be a microservice. Now, if I would try and model this in code, it would probably mean that I would have 4 projects in Eclipse that all define like a single microservice, right? And then I need to deploy 4 Lambdas into the cloud, need to define triggers for them, need to set up a database and configure it. So that's a lot of work. And since it's all sequential stuff that I need to do, right? This will break about each and every rule around microservices, if there are any rules in the microservice world, actually. Right? So it will be really hard to have like a situation where I would say, well, I'm pretty sure everything is in order now. So if I'm updating the microservice or if I'm rolling it out for the first time, I need to make sure that everything is uploaded, configured, wired, whatever, right? So this is hard, if not undoable, if I have to deploy separate Lambda functions. So that will be, well, a waste of your time. Now, if I was about to speak at every conference in the world, I would probably make up a title like this, right? So I want to develop zero-ops serverless microservices running in the cloud, right? That would be a really cool title. That's almost fully bullshit bingo compliant. If I add this using AI and machine learning, now I'm 100% bullshit bingo compliant, right? And I can make up a talk like this with Lambdas and all of the other functionality that Amazon offers. So let's try and see if we can make this reality. Well, apart from the AI and machine learning stuff, because I go to the university this afternoon about AI and machine learning, and then I can edit it. All right. So for this to work, let's meet the little squirrel over here. He's called Sam. And Sam is what Amazon calls their serverless application model. And what this basically is it's like a DSL, domain-specific language, to do service composition. So Amazon reckons that, well, just deploying a single Lambda into the cloud wouldn't really make a difference. Well, hello world is nice, converting thumbnails is nice, but that's about it, right? So if you want to do something useful, you probably have a bunch of services and a composition between those services and some other stuff as well. So databases, message queues, email, maybe just generic compute, GPUs, whatever you need in order for your application to function. So they launched SAM, and they say it's a semi-standard DSL, which means they're the only one that actually using this, right? And hopefully this will be better in maybe a few months, few years, when other serverless implementations start to do something similar. So basically what it is, it's like a description file which describes all of the services and all of the resources that your application actually uses. And in practice, this is like an extension to AWS CloudFormation, and CloudFormation is a way to create templates in which we describe, oh, I need to launch 5 servers of type extra large, I need to configure this database, etc., right? So it's an extension to CloudFormation, especially for serverless implementations. So we use CloudFormation underneath. So with CloudFormation, I can create so-called templates which contain all of my resources, and then I can deploy such templates, and then they become stacks, and then I can also do managed updates or managed deletes of those stacks. So the cool thing is, if I deploy like 5 servers and 3 databases, right, then I can also say undeploy, and then it will automatically undeploy all of those resources. So I don't have to individually undeploy them. And the cool thing about CloudFormation is that it figures out the exact order in which I do things, right? Should I deploy the Lambda first? Should I create the database first? Should I create the API gateway first, right? We'll just leave that up to CloudFormation, so we are not bothered with the exact ordering of things. And then when it becomes available, it makes everything available at the same time. So we're in a consistent state. Now, this calls for demo. So let's go back to Eclipse once more. Let's close the ugly code from the previous example. And let's go to this project. I've called it To-Do CRUD project. So in this case, I have like a typical to-do service that everybody builds, right? And then, in order to do CRUD on to-do, I need both something of a model. So I have like a to-do item. In this case, the to-do item is like a POJO with a annotation, with a couple annotations actually, that could map this POJO to like a DynamoDB table. And this is, well, if you know JPA, then this looks familiar, right? So it's just mapping of a POJO to a table. Nothing special. And then if you look at my collection of functions in this package, you see I have functions to create an item, to delete an item, to read all items, to read a single item, and then do an update item. So basically, there's like 5 Lambdas in here. Now, if I would create each of them in a separate project, I would have 5 projects, would have to do 5 deployments, 5 times configuration, etc. But now, I'm using SAM, so I open up the serverless.template file. Oops, hopefully that plays along. There we go. And using this template, I now have a description language in which I can describe all of the resources that I will be using for my microservice project. Right? So it's versioned, but the version is Serverless-2016-1031. Interesting version scheme. And then I have a bunch of parameters. Well, you could say they're like global variables, just like you see with Ant or Maven, right? So a couple of parameters which I can configure later on. So for example, I have a DynamoDB table, and then I can configure the name for the table. In this case, it's going to be to do, right? Then I need to set something about read capacity, write capacity. This is some configuration that Dynamo takes. I will not bore you with that. And then there's a bunch of resources. Now the resources for this project are, of course, a DynamoDB table. Right? I need to have the to-do table. So I set up the table, and since this is all schema list, the only description that I give here is actually the field that holds the primary key for this table. So of the to-do table, I only describe one field which holds the primary key for every entry. And then I pass on the read capacity, write capacity in the table name using refs over here, and they refer to these properties over here. So first resource is the DynamoDB table. So now I've described that. I can scroll down, and then the second resource that we'll see is called createItem. And this is of type serverless function. So this is a Lambda function in this case. So then I can set all sorts of configuration. So a function name, the handler name, in this case is just the class name, and then it figures out what the actual handler implementation function is. I can set a description. I can set the memory size, the timeout after which it will be cut off. I can set the role. In this case, all of the roles within IAM are uniquely identifiable using this versioning scheme. Right, so I can just point it to a fixed role. I can also make this role a reference, so I can set it up in the properties later on. And then I can also pass environment variables to my function. So in this case, I'm using the name of the DynamoDB table as an environment variable. So as soon as the function launches, it will figure out the name from the environment variable, which also is a ref, and then it knows what table to talk to. Then, for this function, you see I have events, and so the events are triggers. So I define the trigger for this function on the fly. Right? Or in this case, the event type is of type API, which will make it an API gateway definition. And now I said, well, I define a path /todos and then a method post. So if anybody does a post on /todos, that will trigger this create function. Makes sense, right? Now scroll down, then there's the third resource. In this case, it's readItem. Now, readItem is a little bit boring. The interesting, because you've already seen the createItem, the interesting part about this is actually the definition of the API. Because it took me about 2 days to figure this out. And that's, well, maybe tell you something about me, but it also tells you something about the state of the documentation, right? Which is horrible. Right. So this is just stuff that you have to figure out from Stack Overflow or other people who are really annoyed that this isn't working out of the box. So yeah, in terms of documentation, they can really do a better job. But I'm showing it to you now. So this is how you can pass a resource ID. Well, basically, it's a get operation, so it works the same. So I'll scroll down to another one, read all items. And I'm scrolling down to this one because it has 2 events. So during the break, I had someone coming up to me and say, well, can I do multiple triggers for the same Lambda function? And the answer is yes. So in this case, I trigger an API gateway configuration. So a get on /todos will give me all of the to-dos in the database. But I also trigger using a schedule. So every 1 minute, I will basically trigger this function to give me back all the to-dos in the database. Just to show you that you can have multiple triggers on the same Lambda function. Right? And then there's an update, there's a delete, and that's about it. So now I have a description for my 5 Lambda functions. I described the database which it needs. I described the API gateway configuration. And I also described a trigger that will every now and then list the contents of the database, right? So this is about to look like a real microservice because now I have everything configured as a single deployment. So the next thing which I can do then is, and this will take a little bit of time, is actually deploy this. So I say on my project, I say Amazon Web Services, deploy serverless project. Once again, needs a little bit of configuration, so I point it to the correct region. I still run everything in Ireland. I point it to the bucket in which it will upload the zip file containing all of the sources, all of the implementation code. Well, before I do this, maybe I should show you a little bit of code. No, I'll show it when it's uploading. So then I have to give it a name. So let's call it the to-do microservice. All right, let's press next. Then I can override the parameters, like the global variables, which I showed you in the SAM file. So I'll leave that to the default ones, and then I press finish. Now we'll start uploading this. This is a pretty big deployment. I think it's like 65 megabytes. So depending on the Wi-Fi speed, it might take a little bit. So I'll just run it in the background, and I'll show you a little bit of implementation. So for example, if I go to the create item implementation. So first off, in the handle request, right, you see that I'm getting a gateway request as input. And the reason I'm now using a gateway request instead of a to-do item being mapped to JSON is because I want more fine-grained control over either the operation or the return value or whatever. So in this way, using a gateway request, I map this to operations of the API gateway. And then I'm figuring out some configuration. So I want to know what the table name and the region is. So if they are supplied in terms of environment properties, I will use the environment properties. If they're not, I'll set them to default values. Then the interesting part is actually here, where I use the DynamoDB client builder to actually create me an API for Amazon DynamoDB. And then I'm going to use a mapper, which is able to do some mapping between the object and the database table. And since I'm getting the gateway request, so I'm basically getting the raw JSON now, I need to do a little bit of magic in order to map that using Jackson here. So I get the incoming body and I'll map that to a real object, a Java object. Then I set the ID of the object and then I save it using the mapper. Right? And then I'll convert it back to JSON again with the ID so I can return it as a response of my create method here. So I create a new gateway response, give it a 200, and then I pass in the JSON of the newly created item. Right, so now the other CRUD functions are actually pretty similar. So let's see how it's doing. It's still deploying. Okay, there we go. So great timing. So when it's done uploading everything into the cloud, you'll see that it triggers an overview screen here, which will actually show me CloudFormation in action. So Amazon is now interpreting my SAM file, and it will then start to create all the required resources. So it creates a database, it creates the triggers, it creates the API gateway, and it figures out the exact order in how to do things. It also figures out the new IDs for all of the services based on either my description or on some default values. Now it still says create in progress, so we have to wait a little bit before this is done. Yeah. Question?
Where's the link between the function that you define in your SAM file and the actual code of the function?
Okay, so the question is, how is the actual function implementation linked to the SAM file configuration? So if I go back to a definition of a function, so for example the create item here, right? So it has a field called handler, which is create item, and that's the class name over here. So using SAM, I link him like this. I could also supply a fully qualified class name here as well. Okay. So let's go back to the overview screen. It still says create in progress. Once again, it's the cloud, right? So sometimes we need to help it a little bit. It says complete. All right. So now, if I switch to the web console again. Let me switch to CloudFormation just for a second. Let's refresh, it says complete. So now I have a CloudFormation stack rolled out, and this stack has a description for all the resources. So what I can do is I can say, well, for this stack, delete everything. Not going to do that now, but delete everything, and then it will delete my database, it will delete my 5 microservices, etc. So I have a little bit of more fine-grained control of everything, and I can create a composition out of it. Otherwise, for example, when I go back to my Lambda management console, I go back to my function dashboard, we now see that there's a bunch of extra functions, and this list will grow and grow and grow. And this is a flat list. So if you have like multiple teams creating functions, and you have like a couple hundred functions, this will be a mess. Nobody has the overview of what will actually happen, just like database triggers, right? You know they're there, you think they know what they're doing, and then something unexpected happens, and you're on your own figuring it out. So using this concept of the stack, I now have a hold of these 5 individual functions, and I can undeploy them, update them, delete them, whatever. So let's go to one. In this case, let's go to the create to do item function. I can show you the trigger for it, and it has the API gateway trigger. And then using this, I can navigate to the API gateway. And it shows you the API for this. So it has a /todos exposed with a get and a post operation mapped onto it. And then it has a /todo/resource ID with a delete, get, and put on it. So I can get an individual one, I can delete an individual one, and I can update an individual one. So let's start with the post. So in this case, I can say, let's open the test screen for this one. And let's try and insert an individual to-do item. Do I have one here? Right, here it is. Right, so I'm just posting it to the generic endpoint /todos post, and I'm pasting in a request body, saves me a lot of typing, and I press test. Now we gotta have a little bit of patience, because apparently the DynamoDB builder takes a lot of time. So the first time I actually run this, it can take up to 20 seconds for this to actually initialize. And this is a little bit of a, well, that's annoying, because if this was supposed to be the backing function for mobile application, I think your user has already deleted the application by now, right? So now that it's warmed up, if I run it again, it will be much faster, but it will actually take, it has a 21.5 second latency, right? So this is a lot. So there's tricks to dealing with this by using static helper objects, which will be loaded when your code loads. This will prevent you from creating the DynamoDB client API each and every time your function handler loads. So that's more advanced stuff. But for now, we just pay this penalty. All right, so it gets something back, which is an ID, name, and description. So apparently there's something inserted. So let's open the DynamoDB wizard here. Let's refresh this, and it should have a table. It has a to-do table. And then I can look for items. So it now also has an item. And there we have it again. All right. So I can insert some more. So I can go to the console and do a create item with curl. But before I do this, I need to figure out the name of the API, which I've just exposed. Right, so it gets a temporary. So I figure out the API name. And I can copy this. Well, skip it. And let's try and insert. You see it's much faster now. So now I have 2 items. But we had another service which was actually listing them every once in a while. So if I go back to the web console, Lambda management dashboard, I go to functions, and there was this read all to-do items function, which can be triggered by 2 separate events. It can either be triggered by a get call on the endpoint, or it has a CloudWatch event attached to it with a rate of 1 minute. So every minute it will list the contents of the database. So let's see if that actually works by going to the logs. And you see that every minute there's a little bit of logging. So at first it found 0 items, then it found 1, and then if you wait long enough for another run, it will probably find 2 items. Well, in this case, so the question is, the function, doesn't the function return anything? Well, it does return anything, but in this case, I'm interested in just the logging, how many items it found, right? This is just for demo purposes. But if I call it from the command line, if I just do a curl on the /to-do, right, then it will return us all of the items in JSON format. All right, so what have I proven now? Well, I have proven how to actually do microservices using this if the operation that I'm trying to model consists of multiple functions. So instead of deploying each and every function, myself and making sure that everything is consistent once it is in operation, using SAM and service composition, this is actually the way to do it. Now still, if I switch back to the Lambda console, right, still the list goes on and on and on, right? So if this is your pair of eyes onto your collection of functions, then it will get hairy very quickly. So just as with microservices, the trick is not in creating microservices. The trick is in transforming your organization. So your organization should be compatible with this way of development. So you should have teams which are fully responsible for creating and running the function in production. Now, if there's like a list of 100 functions, right, but I have separate teams who know everything about their functions and whether they're operating normally, right, then you still have everything under control. But if this is your pair of eyes on the list of functions, then it will be messy pretty quickly. Okay, let's switch back to slides. So I think by now we've seen how not to do it. We've seen a couple of pretty useful examples, but then people are also doing other stuff with Lambdas. So one of the use cases that you see a lot is that people use Lambdas to actually build custom CI/CD pipelines. So for example, if they are all in to the Amazon cloud or some other cloud provider, they can also use Amazon to store their version control, right? Or to use version control by Amazon. So they have their own Git implementation called code commit. And then you can just supply a commit hook and say, well, if somebody commits something into the version control system, then that should trigger a Lambda, and this Lambda can then start off a whole build, test, deploy process, right? And there's several ways to do it. You can do it completely with Lambdas, or you can do it using a Jenkins image that you probably run on an EC2 instance. So you just have your Jenkins server. Yes, that's like a normal server. So you take care of it, you maintain it, you run updates, etc., etc. But then you use the Lambda to trigger a build or whatever. Or if you don't want to have the Jenkins image, then you build everything yourself in a build pipeline, right? So it's interesting stuff. There's a documented example, I think it was by Expedia, who gave a presentation at last year's reInvent. You can actually look it up. I think I have a link to it later on in the presentation. And they say they built their build pipeline entirely on Amazon. And they have calculated that every time somebody does a code commit and it triggers a CI/CD build, that it costs them about $1. Right? So for every build that they deploy into production, it will cost them $1. That's a pretty interesting use case, right? You can sell that to management. Probably a lot cheaper than having your own data center supporting this. Then there's other cases that people use this for. And I already mentioned that we can interact with services like Amazon Lex, which is voice and text recognition, right? So you can use this technology to either build bots or to do voice control. And particularly voice control is interesting, right? Because this way you can get Lambdas into your living room. So that screams for demo, actually. So in this scenario, we have a device, in this case the Amazon Echo, which is Amazon's implementation of a home assistant. There's multiple devices. There's the Echo Dot, which you see on the picture over here. There's the old Echo, which I have on the desk over here. You turn up the volume, actually. And there's now also new Echo devices which also have video displays. right? So they're constantly coming up with new features for the device. And then you can actually talk to the device, send in a voice command, which will then be interpreted using Amazon's Lex in the backend. And then, using the so-called Alexa Skills Kit, I can translate the voice command into something triggering my Lambda function. And this is actually pretty cool, because once you can trigger custom code, you can do about everything with voice commands. So, as a quick demo, let's go back to Eclipse. Let's close everything. So for this, I have created something which looks a little bit different from the handlers which I've shown you earlier. So the principle is still the same. So we have a handler which basically takes input and then supplies you with output. In this case, this handler is a little bit different because it's a little bit on a higher level. So what this does is it extends a speechlet request stream handler. So it's a little bit different beast from the function that we've seen so far. And what this piece of code actually does is it registers the application ID of the application for the Echo device that I'll show you in a minute. It registers that ID to this Lambda. So it knows that when somebody triggers that application, that it should actually trigger this function. And then, in the constructor over here, I just launch a new Hello World speechlet, and I pass in the application ID, and that's about it. So now I just basically instantiate a class, a speechlet, my speechlet, the Hello World speechlet, and and that actually does the trick for me. So in the Hello World speechlet, this thing is actually a bit like a servlet. Basically, well, it actually is a servlet because it's built on the Servlet API. So the team building the skills for the Echo device, they were a separate team from the Lambda team, and this is how it's converging these days. So they built everything on top of the Servlet API. So a speechlet is basically a servlet with some added value. So we see a similar method to a do get, do post, but in this case we see a on session started, a on launch, a on intent, etc., etc. Right? So it's a similar interaction model that we are used to when programming servlets. Now I'll get back to this code in a bit, but I want to go to the other side of things. So in order to build skills for your Echo device, you don't have to you not only have to have a regular Amazon developer account, but you also got to have a developer account that supports building skills. Right? It's free, right? So you can just sign up for it, and then you sign into the developer console, and you can start building skills. So in this case, I want to go with the Alexa Skills Kit. So Alexa is the wake word for the device, so I try to avoid it a little bit. So let's get started. And now we see that there's a Hello World skill in here. So I can open that up. And I can configure the skill. So this is just configuration. The actual what the skill is actually doing is in the Java code. Right? So for this, I need to set up some skill configuration. So and then I get appointed a application ID for this skill, which I then copied into the Java code. So this is how I hook the two together. Then I have to give the skill a name, so I call it Hello World, and I have to give it an invocation name. So when I issue a voice command, this is the invocation name, which I will use later on. So I just called that demo. Then I go to the next screen, and then what I should configure is so-called intents. So a skill has a couple of pieces of functionality, and a piece of functionality of a skill is called an intent. And you can have one intent per skill. So in this case, I have a very simple skill, which just has the Hello World intent, so it knows how to say Hello World. But if the skill is more elaborate, it can have more ways of interaction. So then it usually has a whole bunch of intents, right? And depending on the intent, I can enter a session with it, and then I can issue it several voice commands. So you can build a game, for example. So you say something to the device asks you a question, you answer, and you go to the next question, etc. So you can build up a session just like with HTTP clients. The next thing that I should configure is so-called utterances. So utterances are basically example commands that I can issue to the device, so it knows how to. From the command I give to the device, it knows which intent to invoke. So I can give a couple of examples of how it can interact with the device, and then the skill is smart enough that if somebody says something similar to this, it still knows which intent to invoke. Right, so now I have only one intent, so if I issue one of these commands, it will invoke the hello world intent, which will then invoke the code running in the Lambda. Right. So well, then there's more configuration which I can do. This is advanced stuff, and then I can go to a test screen, which is also interesting. So I can enter some of the utterances that I have in mind, and then I can test whether it actually works. I will just do a live test later on. And if I'm keen on publishing this skill, so other people can install it on their Echo device, then I can go through a whole submission process. So I need to supply a documentation for it and instructions, how to work with it, and then I can submit it for verification, and if it's verified, then it's going to be published in the store. That's actually cool, and I can even earn some money with it. All right, so basically what this does is just triggering my Lambda function. That's actually the only thing which comes from this, and it defines the interaction model. So what kind of commands can you give to this Lambda? So then if I go to the Lambda console, I have my hello world skill over here. Right. It has a trigger in the form of the skills kit. And in order to configure this, you need to go to the developer portal. That's the thing that I just showed you. Right. So that's how everything is hooked together. So then coming back to the code, now when I actually run this, I just issue a voice command, and then the device will actually try and respond based whether it can map the utterance to the intent. So in this case, I hope it works. I'll stand close so you can hear the response through the mic. I say, Alexa, ask demo to say hi.
Hello all. I hope you are doing well, and that you are having a blast at Bert's Serverless Deep Dive Talk.
Okay, so that works. So basically this is my hello world message. Thank you. Right, so in this case, there is like a get hello response method implemented here, where you can just, well, in this case, just have like a simple string with text. This is the most basic way of putting in text. If you want specific pronunciation of certain words, you can, they have like a special DSL language to put stress on certain syllables or to up the pace of the sentence, or to have explicit pauses somewhere in the sentence. So you can configure all of this. But what I do here, I just have a string. I convert it into a so-called simple card, and then I issue that card as output. In this case, it's very basic hello world thing, but you can imagine when I activate the application, in this case the application is called demo, when I activate the application, a session starts. So while the session is active, I can have multiple interactions with the device. So this is how you create a game, for example. And there's many of those skills available. So they have like a magic door skill, where you say, well, I see magic door. Behind the magic door, there's like if you go left, you see this. If you go right, you see that, right? What do you want to do? And so this goes on forever and ever and ever. So this is how you build actually a session with the device. He's asking you a question, and then you reply back. Actually, very interesting stuff. And well, it took a little bit because it needed to launch the speechlet, right? So that was invoked for the first time, so that takes a little bit of time. And then when I say the wake word, right, it starts recording, or actually it's always recording, right? But then it records the command, and it sends the command to Amazon, which then translates it into something it can understand, like a JSON package with the actual command in it, which will then trigger the Alexa skill. So that's why the little delay. And then you can hook it up to, well, the lights at home or whatever. Right, that's what I do to drive my wife crazy at home, right? So I hook it up to the lights, and then So you can give it like a voice command, well, to turn the lights on and off. That's just basic stuff. But somewhere on the internet I found someone who wrote like a Philips Hue bridge emulator in Java, right? So this means I can hook the device up to my bridge emulator written in Java, and now I just get a command into that emulator, which I can then use to call whatever I like, right? So I can use that interface, right, to do whatever I like in the home, just lights on, lights off, but also do other things with the television or whatever, right? So you can just turn devices on and off, and that's really cool stuff. Because I don't like the services where somebody from the other side of the internet is actually able to access my devices, right, from the outside in. So I don't want to open up my firewall at home. So with this, it just sends the voice command, it gets the command back, and then the pairing between the lights, the Hue bridge, and the device is actually local, right? So nobody from the outside can actually turn my lights on and off, right? So that's why I use the Hue bridge in between. All right, so a little deviation there. This is how we do speech and handle voice commands using Lambdas, actually. That was what was I trying to demonstrate. All right. Now, like I mentioned, Lambdas can be monetized this way as well, right? So there's like a sort of an app store for Lambda, so to speak, or an app store for skills. So if you have some inspiration after this demo, well, write your skill, write your game, whatever. It's a nice way of making some money on the side, probably. All right. Now with this, I think we're done doing the Hello World style demos. Let's talk a little bit about Lambdas in the real world, right? So beyond the Hello World messages. I mentioned Expedia earlier. I mentioned them because there's like a really good presentation from last year's reInvent conference where they're actually explaining what they are doing with this kind of stuff. As you can see from the numbers, this goes way beyond Hello World, right? So what Expedia is doing, well, basically, I hope you know what Expedia is doing, right? They are like they have like a Google search field where you can either type in the name of a hotel, the name of a city, airport, whatever, and then they come up with suggestions for hotels, flights, rentals, whatever. And so as you can see from the numbers, part of what is running behind their search box is now running with Lambdas. And they've also fully automated their CI/CD build pipeline using Lambdas. So they run over 2 billion computations using Lambdas per month. That's quite some compute cycles, I can say. Because it comes down to over 200K hours per month that they're actually burning using this kind of technology, right? That's a lot of compute cycles. It's a big mainframe. And actually, if you look down at the number at the bottom of the slide, they are paying only $550 for this per month, right? So they used to have like half a data center or more to run this functionality. And now using the technology that I've showed you, right, they can bring the bill down to about $500 per month. I mean, that's really interesting business case. And probably, well, since they are doing the talks at the Amazon's conference, they probably get a little bit of discounts here and there. You never know, right? But still, this is huge in cost savings compared to how you do it the old-fashioned way, right? So hopefully this just tingles your mind to think differently about certain implementations that you are using. I'm not saying, once again, this is a hammer, now everything is a nail, so you start to do everything with Lambdas. There can be downsides to it as well. We'll get to that. But you see that, I mean, this is well beyond Hello World, and this is a really interesting business case. If you're interested in the entire story, just do a quick Google for the link on the slide. If you look for SVR 306 at AWS reInvent, you'll find the entire story. All right, then a bunch of pointers when you start developing Lambdas beyond the Hello World scenario. So first off, logging. I think I already mentioned it, but logging and metrics are a universal right. Right, so whatever you do, as long as it writes something to standard out or you use a logger, it will end up in a centralized logging implementation, which will then be picked up by the logging implementation of your cloud provider. In Amazon's case, that's going to be CloudWatch. Through the context API that you have as an input parameter for your handler, you have access to a logger object, basically log4j is running underneath. So you can just supply a log4j.properties file, and then you can configure what's being logged. You can also do simple system out println statements, but in this case you are burning I/O cycles, so this is probably more expensive in terms of runtime, right? So you should be careful with that. Then a few things about testing. So I think it was the first example where I already showed you the unit test, which will be generated by the wizard that is part of the Eclipse tooling. So for simple Lambdas, a unit test is maybe enough, right? If there's just a little piece of functionality. So in my case with the lease calculator, right, there's just a little bit of, date and time wizardry going on, right? That's probably easy to unit test. So you just write a couple unit tests for that, and that's about it. You can just test them offline. And since everything is stateless, that just makes it easy. And if you have some dependencies, then you can just mock them. But as soon as the Lambdas become more interesting, for example, when you think of my demo with the S3 insert, where somebody just uploads an image, and then that will trigger the Lambda, right? This requires to interact with other services. Now, for this, if you would want to test that offline, right, you would need to have an implementation of those services locally. Otherwise, you can't test them, right? And that's a bit of an issue, because Amazon is not really keen on offering you a localized version of their cloud, which you can run on your laptop, right? So basically, compared to other cloud providers, maybe they're really lagging behind on this one, right? So other cloud providers have a stripped down local version of parts of their services available for you offline, so you can easily create unit tests or integration tests that run offline. But Amazon just has a few implementations of that. So for some of their data stores, there is like a local mock of that data store. So you can run like a local Dynamo or a mini version of S3, but not for all of their services. So this is really something that they should work on for the next couple of months, next couple of years. Otherwise, this is pretty much unusable to test offline, unless you are willing to do what the big ballers are doing, and they run tests in production anyway, right? So you can just deploy all your Lambdas to the cloud, but then using the API gateway, for example, you just give them different endpoints. So the API gateway supports staging. So you can have like a prod environment and a dev environment, and then you run your tests in the dev environment, right? Which is not accessible to your normal customers, for example. If you do that, then you will have a solution for integration testing in the cloud. But then there's like one little caveat, which is that there's a maximum number of 1,000 parallel running Lambdas, which is like a default setting, right? So you might run into this. So if you have a couple of popular Lambdas, and you do testing, right, they all add up. So all of the Lambdas running concurrently add up to this 1,000 limit. So you might hit that limit. It's really easy to get rid of the limit. You just email the Lambda support team, and you give them a little bit of a description why you want the limit raised, and then they raise it for you. But you might run into this, and then what you will see is actually that the next Lambda will just be cut off, right? So it's really funny in the logs at first, but then you figure out it's this limit. Configuration. You've seen me use environment variables in the microservice example, right? I used environment variables to configure my Lambdas, right? Don't do hard coding of configuration, please. So using environment variables, you can configure your Lambdas. Using the SAM templates, you can have like a dummy value in the template, and then when somebody is actually deploying your stack into production, they can actually replace the variable values with the production values. So if you're passing in username, passwords, etc., that's the way to do it. But that's just configuration for the Lambdas itself. Then there's a whole bunch of other things you have to configure, especially if you have Lambdas using other services by Amazon, right? Then the roles come into play. So your Lambda got to have a role that has access to the database that you're using, to the logging solution that you're using, etc. So you got to create those roles and permissions. This can also be done using property files. and also using the SAM templates or using the CloudFormation templates. So you can fully automate it, but it's a bunch of extra work. We already talked about the API gateway. That might be cumbersome to configure. Well, using the SAM template is a little bit easier. But if you really want to go all the way, I highly encourage you to describe your APIs as Swagger documents, right? The Swagger contracts, and then upload those contracts. So from the SAM configuration, you can also point to a file which holds the Swagger contracts, right? So you can upload that into the API gateway. And like I said before, the online documentation for this kind of things mostly sucks. I mean, you really got to search for examples on blog posts, or there are some examples. Sometimes it's in Python, sometimes it's in Java, sometimes it's in Node.js. And then you have to figure out how to translate that particular implementation to another language. So this took me a lot of time to figure out in some cases, especially for the API gateway. So hopefully documentation will get better in the future. Then, when it comes to deployments, there's a couple options. You saw me use the IDE plugin a couple times to do the deployments. Everything that the IDE plugin can do is basically also available in the CLI and more. So the CLI is the most elaborate one. So the command line interface, you can just quickly install that on all platforms, right? And then using either JSON or SAML or a YAML configuration, you can actually create deployment packages, you can do the actual deployments, you can set up the staging, you can just pass in each and every parameter into the CLI. And then of course you also have the web console, but the web console is mostly for demos, right? You, especially with Lambdas and with CloudWatch and with API Gateway as well, it just gives you just a few % of functionality of what the actual service is capable of. So you can't do everything with the web console. It's just for demos, for quickly setting things up. It's easy to use the web console. If you want to do more elaborate things, I would advise to use the CLI. Then in terms of CI/CD, we talked a little bit about that earlier on. What most people do is they just run Jenkins on an EC2 server, right? So they just fire up a infrastructure as a service thingy, install Jenkins on it, and then use that as their CI/CD server. But there's other ways of doing it. There's a Lambda plugin for Maven, and you can just use Lambdas to build your own custom pipeline, like I mentioned before, right? So you just hook it up to either GitHub or Code commit, and whenever somebody does a commit, you just fire off your own build pipeline. Now, you can't directly trigger Lambdas from Lambdas, right? So you can't have one Lambda calling into another Lambda. So there must be something in between. So if you want to divide the functionality of the pipeline over different Lambdas, which would be a good idea probably, then you must use something in between. So for instance, you can use the simple notification service by Amazon, which is a quick message queuing implementation. And so when the first Lambda finishes, it just writes an event to SNS, which will then be picked up by another Lambda, right? So this is the way to do it. So it's event-based interaction. You don't call into other Lambdas directly. Or you just insert a file in the database and you have a trigger defined on the insert. In terms of upload size, I find this particularly frustrating. If you do nothing and you just generate a new project, they give you the entire Java SDK plus third-party libs, which will come down to about 63 megabytes of zip file. Now, I have a tiny internet connection at home, unfortunately. So sometimes it took me up to 7 or 8 minutes just to upload a changed function into the cloud. And it's boring, and it takes away all of the focus and attention that you basically have. Right? So make sure you have a big pipeline if you want to upload things. And also really think about your dependencies, right? Because not every Lambda needs 63 megabytes of dependencies. If you do a very simple one, you might not even need 1 megabyte of dependencies. You can just do with the Java libraries, and it's just your piece of code, just a few kilobytes. But as soon as you start using other Amazon services, like S3 or Dynamo or some of the other services, then you need the client libraries for those. Now, instead of adding everything, you can just just figure out your exact set of dependencies and then manually add them to your POM file. So you have the minimal set of dependencies. Now, if you build Java applications, you have to take care of this yourself. If you choose Node, for example, then they already have a bunch of Node dependencies which are available for the Node runtime. So you don't have to include them in your implementation, right? They're already there. So they're provided dependencies. You have to figure that out though, and there's like versioning going on, because what if they change those kind of libraries? Will my Lambdas then break? Answer is yes. So there's downsides to those as well, but the upload size is far smaller than Java services in this case. And well, upload size means lots of classes, and if you start loading lots of classes, then it will also take longer for your Lambda to launch, right? So you pay the price again. Then during the break, I had a couple people come down to me and ask, well, what about lock-in, right? I mean, you talk about Amazon a lot, right? So in this case, we use all of their specific features. So this just seems like a whole big lock-in conspiracy, right? Well, actually it is. There's a bunch of serverless implementations out there, and all of them are proprietary implementation. So if you go to Google, if you go to Microsoft, if you go to Amazon, they all offer you different implementations with different services, different service levels, and also different APIs. So if you choose to go this way, you will choose lock-in. Right, so if you do the simple lease calculator thingy, it's just Java APIs, so there's no lock-in, just a POJO. You can deploy that as easily with Microsoft or with Amazon or with OpenWhisk. But if you start to use specific services like S3 or Dynamo or all of the other stuff that I used before, then you will start to hook into the platform more and more and more, and this will lead to more lock-in. So yeah, well, lock-in is your choice. So it depends on your business case whether you are willing to pay that price, right? On the short term, I don't see any standardization going to happen. Right now, they're still heavily competing. So all of the cloud vendors are heavily competing in this space. So they probably have no, well, there's nothing in it for them to standardize. But in the end, as all of the stacks of the different cloud providers are starting to look alike, they will probably want to have some standard stuff going on. So then maybe we will see more open source, more standardization kicking in, right? For some of the stuff like the SAM DSL, like I showed you. Amazon has open sourced that, but they are still the only user of that project. Right? Yeah. The other interesting thing that some of them are doing, for example, if you look at Project FN, which we will look on in a minute or so, then they have something that if you have an existing Lambda function built with JavaScript, right, then they can wrap that function and then launch it in an FN server, right? So they do some handy wrapping of services that you might have created for other cloud providers. But as soon as those services tap into S3 or whatever, then they don't have any replacements for that. So you need to replace it anyway. Then in terms of performance, well, like we said, JavaScript and PHP are two of the runtime options that Amazon offers you. They're interpreted on the go, so they hardly infer any startup penalty. So if you want to pay the minimum amount, right, then you should probably go with JavaScript. But then you have to take a shower each and every time you write a little bit of code. If you're willing to use a real language, right, then you pay the penalty in terms of firing up the JVM, loading all the classes, loading dependencies, right? So yeah, it's going to be a little bit more expensive. Now, in terms of expensive and expensive, right, is it expensive in terms of just a couple dollars per month, right? Then it's probably, well, you don't even have to think about it. But in some cases, if you have services which are invoked and just take a couple milliseconds, and you are built for at least 100 milliseconds, then you might come up with some scenarios where using Lambdas might actually turn out to be more expensive than using a PaaS implementation, right? So before you start building, you should think about your business case, and you should think about pricing. Now, once again, I don't work for Amazon, so I encourage you to check out all of the pricing details in the account. in your account. They explain it to you nicely, and then you have the option to create rules and triggers which will cut off some services as soon as you go over a certain amount of threshold in terms of dollars, right? Auto scaling, we talked about that, right? The cool thing about serverless is that you don't have to think about scaling functions because it happens automatically. So as soon as new users come in, they start hitting your functions, then Amazon will automatically scale everything. But once again, here's the 1,000 limit, right? So if you hit 1,000 Lambdas running at the same time, then that's the max amount of scaling that you get. But once more, just send the support team an email, and they are happy to lift the limit for you a little bit. So you might say, well, all of the stuff that you showed me up till now is pretty much, low-level, basic stuff, dealing with input and output. I have to know all kind of specifics about the runtime, well, up to a certain limit, of course. Can we have more abstractions, right? Can we come up with something that maybe is able to build functions abstracted away from the underlying cloud implementation? And the answer is, well, there's a couple of frameworks that try exactly to do this. So one of the things that you should definitely check out is a website called serverless.com. And serverless.com basically is an abstraction for creating functions in about any language that you like. And then using some configuration templates, they know how to deploy those functions to a whole bunch of cloud providers. So if you write something in JavaScript, for example, then you're able to deploy that to both Google, IBM, Microsoft, and Amazon at the same time, right? So you have a choice of where you want to deploy those functions. So they try to abstract everything to a higher level. So this is pretty interesting stuff. If you're into the JavaScript stuff, then I also encourage you to check out Cloudia.js, which is a very handy command line tool that integrates well with the CLIs of the different cloud vendors to actually deploy Node.js projects to, in this case, Amazon. So it supports staging and versioning and everything. So it gives you a abstraction, so you don't have to work with either the Eclipse plugin or you have to know everything about the specifics of the AWS command line interface, but you can just use the configuration templates from Cloudia.js in order to deploy. And they have a lot of defaults already going on. So this really helps if you want to deploy microservices using Node.js, for example. Then you might be enthusiastic by now. You might not be, right? Good thing is that you're still here, though. There's downsides to all of this too, right? And this wouldn't be a good presentation if we weren't talking about downsides. So yes, all of this stuff is great, but everything that I've shown you is heavily dependent on the cloud, and in this case also on public cloud offerings, right? And depending on employer that you work for, this might be a problem because you might not be allowed to use those cloud providers. Your employer might not like Amazon, or they might not like public clouds in general. So what can we do if we are not allowed to run this in public cloud, right? Do we all forget about this, or are there other options? Well, there's a bunch of other options actually. First off, if you like the idea of having functions and controllers that will trigger functions, then you can just use that as your programming framework. And there's a framework called Funkatron, which is written by David Pollack, who you might know as the original author of the Lift framework for Scala. So David is now back doing Java, apparently, and he wrote the Funkatron implementation, which is just a functions controller style framework. It's really easy to develop with. And so if you like this, then you can build your functions the serverless way, and then you can deploy those functions onto containers, which you can then deploy into your Kubernetes container scheduler, etc. So that might be an option for you, right? If you like this, but you have to run it on-premise, right, then this might be an option. Another option might be to use Apache OpenWhisk. OpenWhisk is being used by IBM in their public service offering, but it is based on the Apache OpenWhisk open source framework, which you can just download and run yourself on-premise, right? So OpenWhisk also takes Docker images as its runtime. So you can configure a scheduling framework that's able to use Docker images, and then you write your functions, deploy them into Docker images, which you can then schedule using Kubernetes or whatever you have. Right? And this does not only power IBM's implementation, but also Red Hat's implementation of functions. They used to have their own implementation, but I think they replaced that recently with OpenWhisk. So OpenWhisk is definitely worth having a look at. And then there's a third option, which is FN, which you already talked about in the intro when I talked to you about interesting implementations. So FN was announced recently. It's an open source project. It's run by the guys that used to write the Iron Functions implementation for Iron.io. I think they're now part of Oracle. And Oracle decided to come up with another serverless implementation called FN. I think somebody at the marketing department wasn't really paying attention, because now you have FN Java, right? Oh, that's actually cool. Or you have FN backend as a service. That's worse, right? Okay, so why another framework? Right, because Oracle says, well, there's a lot of serverless offerings out there, but only some of them are open source, like OpenWhisk, right? And the other ones, like Lambda and also the ones by Microsoft, Google, etc., they're not open source or not entirely open source, right? So let's have an open source one so we can also work on standards, right? So coming back to the question of standards, well, this is by open sourcing stuff, that's an attempt to work on commonalities and also on standards. The other thing is that there's poor Java support in some of the offerings out there. Well, that's true. Google doesn't support Java for functions. Well, Microsoft now does support Java. Amazon supports Java, right? But there's limited Java support, let's call it that way. And there's a poor development experience in terms of there's low fidelity between dev and prod, which means it's hard to deal with stuff offline and online. That's what they're trying to solve. So they come up with a pure Java implementation, but they support a lot of other environments as well. And the interesting thing, though, is whether this still can be seen as a serverless approach. So coming back to my serverless manifesto that I actually started with, if you think about this, and you are now no longer just responsible for writing functions, but also for mapping functions to Docker images and then running Docker images, right? It no longer complies with everything in the serverless manifesto. So basically what we're seeing out here is that there's like a distinction in the part of the framework which is targeted at developers, which just write functional pieces of code, and there's a part of the solution which is targeted at like an ops team, which basically runs the infrastructure for your development teams to work on, right? So with Lambda, for example, Amazon is responsible for everything, right? You just supply your function code and that's it. But with solutions like OpenWhisk and FN, if you run them on-premise, right, then you are no longer attached to a public cloud, right? So you have everything on-premise. But then you should distinguish between developers using the framework and supplying function code and an infrastructure team or an ops team which basically runs the infrastructure underneath. Because underneath this, there's Docker images, there's Kubernetes probably running. And if you are, as a developer, become responsible for running and scheduling containers as well, then it's no longer serverless, because it violates about every bullet of the serverless manifesto, right? So that's how you should think about this. So yes, it's still serverless from a development perspective, but then there's a whole lot of ops involved as well. But probably that can be handled by different teams of people with different skill sets. All right, so let's do a quick demo of FN, just to give you a feel for how it works. I think we have enough time for that. So for this, I go to the command line. And what I did is I downloaded FN. It's a Docker image of the server. So I downloaded it and I actually started it by typing in FN start. And now I have a local Project FN server running. Right? So this is a local server which pretty much acts like a container scheduler, so to speak. Then I have a simple project which I've called Hello Devoxx. And if I list what's in there, there's just one function in there, and just for demo purpose, I wrote it in Go. So if I do a of this function, you see there's a very simple Hello World implementation written in Go. Right? Now, in order to get this started, I say, well, let's do a fn init first. So I only concentrate on writing code. Let's do fn init first. And when I do fn init, it will try and detect the runtime and then create a bit of configuration. So it created a YAML file. And if I get that, you see that it gives it a version, it gives it an entry point, and it determined the runtime to be Go. Right? It supports a whole lot of runtimes. Go is just one of them. Java is another, and there's many, many more. Right? So now I have my function set up, and then I can actually run it. I need to make sure that I know the commands. So in this case, very simple. It's fn run. So what I'm doing right now is I will create a Docker image on the fly based on my function. The Docker image contains the runtime for this function to run, and then it will basically invoke the function. So in this case, as a result, we get the hello world message. Right. So this is like a local test. I can now locally develop the Docker image and then do an isolated run of the function on my laptop. Next thing that I can do is I can deploy this thing. Oops. I can deploy this thing. Now it creates a new Docker image, and then it will deploy that. Oops, I haven't set. Okay, before it does that, I need to make sure that I set my Docker registry name, because it will immediately upload the thing to my Docker registry. I think it's this one. Try it again. So it will push the image into my Docker registry. It can either be the public Docker registry, or it can be a local registry that I set up. And then it will hook this image up to the server, which I have running in the other window. So we'll attach that. And then I also have a user interface running for this. So, oops, in the other browser. There's a UI. And now we can see that there's a bunch of applications available in the server, and Hello Devoxx is one of them. So in this case, I can go through the server to this route for this application, and then I can even invoke the service. So in this case, I can just run it. And then it gives me the end result back, and I can also curl it, so we have an endpoint. So through the server, we now have an endpoint to this local function. Now, of course, I'm running everything in a very simple setup on my laptop here, but imagine this to be a little bit of a bigger scale, where you supply a whole bunch of servers, you run Kubernetes on top of this, right? And then using the event server, you have like a load balancer for your functions, and then you can do basically everything that I've shown you before using Amazon Lambdas, but now you run it on your own infrastructure using similar technology, right? And then FN adds upon this by also thinking about how to deal with stateful functions, and also how to orchestrate flows over different functions. So there's a whole bunch of interesting aspects through this serverless implementation. So it's definitely worth checking out if you have the time. So going back to slides for a bit. Now, I think so far everybody finds that there's some coolness to this serverless thingy, whether you perceive it as database triggers or as something more advanced, right? I think it's good that you understand that there's a bunch of other drawbacks that we haven't yet discussed. So we talked a little bit about vendor control and lock-in, right? Everything's basically proprietary. You do have some escapes with some of the open source offerings like FN and OpenWhisk that I just showed you. But then lock-in, especially if you use other services, is still very much a choice, which you can either go with or try to avoid. Other things that you will quickly run into if you start to use this on a bigger scale is that there's no support for multi-tenancy. in serverless implementations. So this means that if you want to use the same Lambda function over different customers, right, then you have to come up with a solution for this yourself. Now, this is not that hard, of course. If you just pass in an ID somewhere, you can distinguish between different customers or different clients. But for simple things like this, which we have solved many times before, there is no support yet, right? So this is something to think about. Then there's security concerns in terms of if instead of writing one application, we are now writing lots of separate functions and we expose them to the outside world, then what we're basically doing is we are opening up the attack surface, right? We are increasing the attack surface. Now, of course, there's always something in between. So in this case, there might be an API gateway in between, which you can then secure, right? I didn't demo that, but you can, of course, secure the API as well. But still, you just have a broader attack surface, so you should just be aware of that. Then, if you've written code now that is highly optimized for a specific server instance for your particular cloud provider, right, or does lots of time-intensive calculations, then Lambdas might not be the ideal choice because you have no control over the underlying runtime. As you saw earlier, there's a bunch of startup issues as well. So if I use expensive client APIs, right, then they take like 10 or 20 seconds just to instantiate, right? So that might be a problem. Now, if you have highly optimized code that must run on a particular set of underlying hardware, then Lambdas are probably not a good choice. What you could do in that case is if you have very intensive calculations going on, for example, is that you just use a Lambda to boot up an Amazon GPU instance or an XL instance, for example, EC2 XL instance, then run the piece of code on it, and then as soon as you're done, you just kill the instance, right? So you still have this idea of paying while you go, but you have the Lambda actually managing the other cloud resources. So that's probably a good implementation of Lambda, but coding against the underlying mechanism and trying to optimize against the underlying implementation of Lambda, just to get the most out of it, that's probably not a good idea. Or instead, that's not a good idea. Then your execution time is limited. I mostly configure just a couple seconds for my Lambda to run. That's basically cost control, like I mentioned before. But there's also a hard limit on a maximum hard limit. So I think it's 15 minutes, right? So that's the longest runtime for a Lambda. So after 15 minutes, it will be killed. Probably this is worth sending an email to the support team again. Maybe you can up it a little bit. But eventually there will be another limit. So then it will probably be 20 or 25 minutes, right? So there's limits to the amount of time for running a single Lambda. So if the runtime is critical, in that case you might have to think about other options. We talked about performance and startup latency before, so I'm not going to repeat that here. Talked about testing as well. We haven't talked about discovery yet. The only way we discovered Lambda so far was through the web console, right? So we opened up the Lambda dashboard and then we saw this flat list of Lambdas. Now, there's no ways where Lambdas can directly discover other Lambdas, right? So we don't have a UDDI for Lambdas yet. Probably some vendor will probably come up with that eventually. But you have different other options. So you can, of course, go outside in. So you can do HTTP calls into the API gateway. Or you can just chain them together using an eventing mechanism. But this is brittle, right? Because you're not entirely sure the Lambda is there, whether it's deployed or not. So if you want to be sure about that, then they have to become part of the same application model, right? So you use SAM in order to make sure that all of the Lambdas which you are dependent on are then part of the same stack. And this might then again be brittle or might be hard to release, but because then you just couple each and every Lambda to each and every other Lambda in the system. That's probably not the idea, right? So Lambdas, discovering and calling Lambdas directly, that's not really supported. And if you have a use case like that, you should probably rethink the use case. All right, with that, we're almost out of time. I think we have like 10 minutes left or so. I just want to do a quick summary. I think in general, serverless is a really interesting paradigm, which is now being embraced by most of the major cloud players, right? and everyone else is creating functions and frameworks and whatever implementations for it too. So yeah, this is heavily being picked up. It's going straight to the top of the hype cycle, right? The interesting idea about this is that we are loosening the concept of an application, and we go for functions instead, right? And these functions can be triggered using events. They're both stateless and transient, and you have no clue what the underlying sandbox is actually doing, right? The cool thing about this is that it's infinitely scalable, well, at least up until 1,000, right? Where the scaling is being taken care of by the cloud provider, not by you. So this saves you a lot of worries, and this also enables really interesting startup scenarios where you can start with a little bit of money, and then eventually when you become popular, and then when the money will be flowing out of your system, right, you can use that money to invest back into the Lambdas. It's kind of different from traditional deployment models. There's a little bit of resemblance with PaaS, but only a little bit, because we have no notion of servers, no notion of applications, no notion of scaling up, scaling down. Right? And the cool thing about this is it's truly pay-as-you-go. So we only pay for when actually our functions are being run, and we don't pay for hot standby or cold standby. So we are giving the cloud a run for its money now, instead of the other way around. I think that in theory is very, very interesting stuff. Hopefully you have all kind of use cases in your head now that you want to experiment with. I do have to say that this is still a relatively young technology. The ideas from Amazon are now only 3 years old. So there's lots of stuff which will be different in the next couple of months, next couple of years. Amazon is also still doing lots of updates to their implementations. So every month or so, or every 2 weeks, I guess, there's new SDK updates. So there's a lot of stuff still happening in this space. It's very much proprietary, but lock-in is your choice, of course. So with that, I'd like to thank you for your attention. If you have any questions, you're free to ask them now, or just come down, and I'll be around for the next couple of days. So I'll be around to answer your questions. Thank you.